All right, here we go. Next chapter in geometry. We'll start with section 1, properties and attributes of polygons. And it reads, each segment that forms a polygon is a side of the polygon. The common endpoints of two sides is a vertex of the polygon. A segment that connects any two non-consecutive vertices is a diagonal. So again, our vocab words are side, vertex, diagonal. And you should know these names. And it reads, you can name a polygon by the number of its sides. The table shows the names of some common polygons. Like the first one, if it has 3 sides, you should know that's a triangle. 4 sides, quadrilateral. 5 is pentagon, 6 hexagon. 7, not so popular, heptagon. 8, think a stop sign, octagon. 9 is nonagon. 10, decagon. 12 is dodecagon. And n sides is n-gon. In other words, we don't have names above 12. So if a polygon has 13 sides, it's called a 13-gon. Yeah, pretty fancy name. If it has 14 sides, it's called a 14-gon, 15-gon, 16-gon, and so forth. We don't have specific names above 12. Well, this one says, tell whether the figure is a polygon. If it is a polygon, name it by its number of sides. Well, yes, it is a polygon. How many sides does it have? Let's number them. 1, 2, 3, 4, 5, 6. 6 sides makes it a hexagon. The next one, is this a polygon? Yes, it is. Let's number our sides. 1, 2, 3, 4, 5, 6, 7. 7 sides makes it a heptagon. So an arrow is a heptagon. The next one, is this a polygon? No, it is not, because of this curve right here. So a half moon or quarter moon, whatever that is. In a polygon, all your sides are straight. So this is not a polygon, so we don't name it. This next one is not a polygon because it's open right here. A polygon is closed, like the fence is closed so the cows couldn't get out. This is open, so it's not a polygon. This next one, everything is straight, it's closed. Yes, it is. Let's number our sides. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. 9 sides on our list is a nonagon. So it's a polygon, and the more specific name is nonagon. The next one we have this curve again. So no, it is not a polygon. All right, some more definitions here. It reads, all the sides are congruent in an equilateral polygon. All the angles are congruent in an equal angular polygon. Big vocab word. A regular polygon is one that is both equilateral and equal angular. If a polygon is not regular, it is called irregular. To be regular, all of your sides are congruent to each other, and all of your angles are congruent to each other. Some more vocab. A polygon is concave if any part of a diagonal contains points in the exterior of the polygon. If no diagonal contains points in the exterior, then the polygon is convex. A regular polygon is always convex. So concave, think of it as it's caved in. So tell whether the polygon is regular. Well, are my sides congruent? I see 1 tick mark, 2 tick marks, 3 tick marks, 4 tick marks. So the sides being congruent, I'd say yes, they are. But look at your angles. I see 1 tick mark, 1 tick mark, but I see 2 here and 2 here. So my angles are out. So it's irregular. Tell whether it's concave or convex. Well, is it caved in? No. So it's convex. Concave and convex. Look at the next one. Is this regular? No. Are all my sides congruent? No. So this one is irregular. Is it concave or convex? Well, if I connect my diagonals, like right here, you can tell that these corners are kind of caved in. And if I were to extend this side, you see how the extension goes into the interior? That means it's concave, because the corners are kind of sunken in a little bit. So concave is my answer there. Let's go to the next one. Is this one regular? Well, it looks like all 4 sides are congruent and all 4 angles are right angles, so that means they're congruent. So this is regular. Is it concave or convex? I don't see anything that's sunken in, so it would be convex. How about this one? Are all my sides? I have 1, 2, 3, 4, 5 sides that are congruent, 5 tick marks, and I have 5 arc marks. Yes, this is regular. Concave or convex? Well, I don't see anything really sunken in, so it's not concave. That means it has to be convex. The next one, is this regular or irregular? Are all my sides congruent? No. Irregular is what it is. And you see this end here, how this is kind of sunken in. That means it's concave. It's caved in. It's how I like to remember it. All right, time for a theorem. In each convex polygon, the number of triangles formed is 2 less than the number of sides in. So So the sum of the angle measures of all these triangles is n minus 2 times 180. What does that mean? Look at the theorem here. 611. The sum of the interior angle measures of a convex polygon with n sides is n minus 2 times 180. Well, what does that mean? If I have a triangle, n is 3 because it has 3 sides. If I have a square, n is 4 because it has 4 sides. Well, back to the triangle, what's the measure of these 3 angles combined? Well, we know it's 180, but using the theorem, it's n minus 2 times 180. In other words, 3 minus 2 times 180, or 1 times 180, which is 180. In a square, it would be 4 minus 2 times 180, or 2 times 180, which is 360, which means all 4 of these angle measures would always add up to 360. Well, my question here on this slide is find the sum of the interior angle measures of a convex heptagon. Well, how many sides is a heptagon? Heptagon, look back to your very second slide, is 7 sides. So the formula would be 7 minus 2 times 180, or 5 times 180. That requires a calculator. 5 times 180 in your calculator would be 900. Which means if you have a heptagon, which is 7 sides, and you take all 7 angles and add them together, they would total 900. The next one, find the measure of each, switch it up here, each, keyword each, interior angle of a regular 16gon. In other words, n is 16. So my formula is 16 minus 2 times 180, which is 14 times 180. So 14 times 180 is 2,520. In other words, if you draw a 16-sided polygon and measure each of the 16 angles, they would add up to 2,520. But this is regular, so each one is equal. Each of the 16 angles is equal. Well, my question is, what does one of them measure? What I have to do next is take 2,520 and divide it by 16. And I get an answer of 157.5. So each angle is 157.5. The next one, find the measure of each angle. Oops, that's the same one. Need to advance. Here we go. Find the sum of the interior angle measures of a convex 15. So this one says sum, so I won't divide by 15. N is 15, so my formula is 15 minus 2 times 180, which is 13 times 180. Calculator, 13 times 180 gives me 2,340. Okay, that's the sum of all 15 angles. I don't divide by 15 on that one. Almost done. New theorem. We just talked about the interior angles, now the exterior angles. The sum of the exterior angle measures, one angle at each vertex, of a convex polygon is 360. It doesn't matter how many sides you have. If you have 3 sides, the 3 exterior angles add up to 360. If you have 4 sides, the 4 exterior angles add up to 360. If you have 1,000,000 sides, the 1,000,000 exterior angles add up to 360. Question. Find the measure of each exterior angle of a regular 20gon. Well, the total of all 20 angles in the exterior is 360. Each one I would divide by 20 to find each one. So 360 divided by 20 is 18. So I have 20 angles that total 18. Because now I've switched gears. I did talk about interior angles first, now exterior. Well, look at this last diagram here. This kind of shows the exterior angles a little bit better. Find the value of B in the polygon. So let me circle the exterior angles. We have a 33B, a 16B, 10B, 28B, 15B, and 18B. If I add those together, so I'm going to pick up my calculator, and I'm going to put in 33 plus 16 plus 10 plus 28 plus 15 plus 18. That comes out to be, if I add them together again, 120. B. So all, what's that, 6 angles added together is 120B. And that equals, what number again? Equals 360. All I have to do is divide by 120. So B equals 3. 360 divided by 120. Okay, and that's our notes for 6-1. Thanks for watching.